In this video, I will discuss higher derivatives. Higher derivatives designated by the symbols in terms of dy all over dx. The second derivative, which is the derivatives of the first derivative, is d squared y all over dx squared. And the third derivative, which is the derivatives of the second derivatives, is d cubed y all over dx cubed. And the fourth derivative, which is the derivatives of the third derivative, is d raised to the fourth power y all over dx4. And the nth derivative is d raised to ny all over dxn. Other symbols are in terms of y. The second derivative is equals to y double prime. The third derivative is y double triple prime rather. Then the fourth derivative is y to 4 power. Then the n derivative, which is y raised to n. And in terms of functions of x, the second derivative, which is functions of x double prime, and the third derivative, which is functions of x triple prime, and the fourth derivative, which is functions of x 4, and the nth derivative, which is functions of x raised to n. For example, number 1. Find the second derivatives of y is equals to 3x squared minus 4x plus 1. So meaning this expression y is equals to 3x squared minus 4x plus 1, we're going to evaluate twice since the required is the second derivative. Therefore, the first derivatives of these functions is equals to dy all over dx is equals to the derivatives of 3x squared using product rule. Just multiply the exponent by the coefficient, or 2 times 3 is equals to 6. Then just copy the base, then subtract 1 from the exponent, and that is becomes 1. So therefore, the derivatives of 3x squared is equals to 6x. Minus the derivatives of 4x. Since x is variable and the derivatives of variable which is equals to 1, therefore 4 times 1 is equals to 4, plus the derivatives of 1 which is constant is equals to 0. To simplify, the derivatives of y with respect to x therefore is equals to 6x minus 4. And the second derivative, which is the derivatives of these first derivatives. So therefore, the second derivatives is equals to the derivatives of 6x, since 6 is constant, multiplied by the derivatives of x, which is 1, therefore the derivative, which is equals to 6, minus the derivatives of 4, since that is constant, is equals to 0. Therefore, the second derivatives, which is equals to 6. Problem number 2. Find the second derivatives of y is equals to the quantity 2x cubed minus 3 closed quantity raised to the 4th power. To determine the derivatives of this using power formula. The derivatives of y with respect to x, or y prime, is equals to, just copy the exponent, which is 4, multiplied by the base, which is 2x cubed minus 3, and subtract 1 from the exponent, and becomes 3. Multiplied by the derivatives of the base, 2x cubed, 2 times 3 is equals to 6. Copy the base, which is x, then subtract 1 from the exponent, and becomes 2. Minus the derivatives of 3, since that is constant, is equals to 0. Y prime is equals to 4 times 6x squared is equals to 24x squared. Copy 2x cubed minus 3 raised to the 3rd power. And this is now the first derivative. The second derivative, which is the derivatives of these first derivatives. Using derivatives of the product, the second derivative, which is equals to, just copy the first 24x squared multiplied by the derivatives of the second using derivatives of the product. Just copy the exponent, which is 3. Copy the base, 2x cubed minus 3. Then subtract 1 from the exponent, becomes 2. Multiplied by the derivatives of 2x cubed minus 3, which is equals to 6x squared. minus the derivatives of 3 is equals to 0. Plus, copy this secant, which is 2x cubed minus 3 raised to the third power, multiplied by the derivatives of the first using product rule, or 24 times 2 is equals to 48. Then x squared becomes x. Simplify, y double prime is equals to 24x squared times 3 times 6x squared is equals to 432x raised to the fourth power, then times 2x cubed minus 3 raised to the second power, plus 48x times 2x cubed minus 3 raised to the third power. Y double prime is equals to the common factor, which is equals to 48x, and 2x cubed minus 3 raised to the second power. 432 divided by 48x is equals to 9x cubed, and 2x cubed minus 3 raised to the second power divided by 2x cubed minus 3 raised to the second power is equals to 1. Then plus 48x divided by 48 is equals to 1. Then 2x cubed minus 3 raised to the third power divided by 2x cubed minus 3 raised to the second power, which is equals to 2x cubed minus 3. Then simplify, y double prime is equals to 48x times the quantity 2x cubed minus 3 raised to the second power, then times 9x cubed plus 2x cubed minus 3. Y double prime is equals to 48x times 2x cubed minus 3 raised to the second power, then times 9x cubed plus 2x cubed is equals to 11x cubed minus 3. Therefore, this is now the second derivatives of y is equals to the quantity 2x cubed minus 3 raised to the fourth power. 3. Find the third derivatives of functions of x is equals to 1 all over 3x minus 1. To determine the derivatives of this function using the derivatives of the quotient, the first derivatives of the functions of x prime is equals to, just copy the denominator 3x minus 1 multiplied by the derivatives of the numerator, or derivatives of 1, which is equals to 0, minus, copy the numerator, which is equals to 1 multiplied by the derivatives of the denominator 3x minus 1, and the derivatives of 3x is 3, and the derivative of negative 1 is equals to 0, divided by the square of the denominator. Functions of x prime is equals to negative 3 all over 3x minus 1 raised to the second power. And this is the first derivative. To solve for the second derivative is to determine the derivatives of these first derivatives using derivatives of the quotient. For the second derivatives of the functions of x, double prime is equals to, just copy the denominator 3x minus 1 raised to the second power multiplied by the derivatives of negative 3, which is constant, is equals to 0, minus, copy the numerator, which is negative 3 multiplied by the derivatives of the denominator by applying the power formula, and that is equals to 2 times the quantity 3x minus 1, which is the base. Then subtract 1 from the exponent, 2 minus 1, and the exponent now becomes 1, multiplied by the derivatives of the base, 3x minus 1. And the derivatives of 3x minus 1 is equals to 3 minus 0, divided by the square of the denominator, 3x minus 1 squared is squared. Simplify, functions of x double prime is equals to 18 times 3x minus 1 divided by 3x minus 1 raised to the fourth power. Then simplify. The second derivative, which is the function of x double prime, is equals to 18 divided by 3x minus 1 raised to the third power. And the derivatives of this, which is the third derivative. The same procedure using derivatives of the quotient, just copy the denominator 3x minus 1 raised to the third power multiplied by the derivatives of 18, which is equals to 0, minus copy the numerator 18 multiplied by the derivatives of the denominator using derivatives of the power formula, just copy 3, then multiply by the base 3x minus 1, subtract 1 from the exponent, and now that is becomes 2, and multiply by the derivatives of the base 3x minus 1, which is equals to 3 minus 0, divided by the quantity 3x minus 1 cubed, then is squared. Simplify. The third derivative, therefore, is equals to 162 times 3x minus 1 raised to the second power all over 3x minus 1 raised to the third power times or squared, that is becomes 3x minus 1 raised to the sixth power. Therefore, the third derivative of the given function 1 all over 3x minus 1 is equals to 162 all over 3x minus 1 raised to the fourth power.